So hello everyone and welcome back, and let's discuss about the third problem, which is the maximum path score in a grid. So what this problem states is we have been given a m cross n grid where m is the number of rows and n is the number of columns. And in this grid we will be having the values as 0, 1 or 2, and we are also given an integer value k. Now what our task is that we have to start from a corner left top left corner of the grid, that is 0, 0, and we want to reach to a bottom right corner which is m minus 1 and n minus 1, and we can only move either right or we can only move either down. We cannot move left or up. Okay, so what will be what will happen when we will move? If at any element, if we are at the index 0 comma 0, and if the value at 0 comma 0 is 0, then it will add 0 to our score and it will add 0 to our cost as well. And when we will perform a second move, let's say in that if the value of the element at those indexes I comma j is 1, then it will add 1 to our score and it will add 1 to our cost. And similarly for 2, it will add 2 to our score and it will add 1 to our cost. Now what our task is, we have to return the maximum achievable score without exceeding a total cost of k. Means whatever the cost we will be accumulating, it should not exceed k. That is our task. And our answer will be minus 1 if there are no valid paths from the top, from 0 to from 0 comma 0 to last index. Okay, so let's understand with the first test case, which is this one. Here the value of k is 1 and these are the elements. So let's understand. This is the grid of 0 comma 1, 2 comma 0, and the value of k we are having as 1. I'm taking value of k as 1. So what happens is we are at the 0 comma 0, means we are having the value as 0. So we want to come to this point, this cell, which is the m minus 1 and n minus 1, which is 1 comma 1 in our case, because here m is equal to 2 and n is also equal to 2. So m minus 1 and n minus 1 will be 1 comma 1. So how we can proceed? Let's see that if we are at the 0 comma 0, if we are starting from here, so our initial score will be the element at 0 comma 0, which is 0. And if we are going, if we are present here, then our cost should also accumulate with 0, because 0 will be added to our cost. Now let's see, if we are going from 0 comma 0 to this index 1, 0 comma 1. So what will happen is the element value is 1. If the element value is 1, our score will increase by 1 and our cost will also increase by 1. Now we are here. Now what will happen that if our, now what is our cost? Our cost is 1. Cost is equal to k, right? So we can proceed. Cost should not exceed k. We can only bear at most cost of k. So we are here. Now we can either go right or either go down. Right. So in right we cannot go because there is no element. So we will prefer going down. If we will come at this index 1 comma 1, then what will happen at 1 comma 1? The element value is 0 here. So in score we will be adding 0 and in the cost we will be adding 0. So our total cost is 1, which is less than and equal to k, and our total score is also 1. So we can say that if we are taking the path 0 to 1 to 0, means this 0 comma 0 to 0 comma 1 to 1 comma 1, our total score will be 1, and we have this valid path here because our total cost has not exceeded k. Now in the initial decision, we have made a decision that from 0 comma to 0 we will go right. But there was one more case that we can also go down, right? There will be always two possible cases from every element. As you can see, it will be either right or it will be either down. So we have taken one which is right one option. Let's consider the second option, which is going down. So when from 0 comma 0, if we are going to 1 comma 0, right here I am having from 0 comma 0 to 1 comma 0 to 1 comma 1. So what will happen is our total score will be 0 initially, because at the 0 comma 0 we are having the element as 0. Then we will come to 1 comma 0. So here the total score will be added by 2, but the total cost will be added by 1, because it is given that for 2, add 2 to your score and 1 to your cost. So we have performed those operations. Now we are at this position. Now what we will do is we are at 1 comma 0, means here. So now we will go to right, because we cannot go down, right? So we will go to right. So we will go, if we will go to right, then our cost will increase by 0 and our score will also increase. Cost and score both will increase by 0. So our total score will become 2 and our total cost will become total cost will become 1. And so we can see that the score in the second case is greater, which is 2, and score in the first case is 1, right? So we can say that what our output should be, that return the maximum score achievable. So maximum score achievable in this case is 2. So we will take this path from 0 to 0 to 1 to 0 and 1 comma 0 and to 1 comma 1. We will take this path because here also cost is not exceeding k, but our score is maximum here. So can you see that one thing, that for every index, for every position, like it may be any I comma j, we are having two possible cases that we can either go right, we can either go down, but we are not sure where to go. Either we can go right or either we can go down. So can we say that if we are at any index, like if I'm at 0 comma 0, it 0 comma 0 can be any I comma j, I would say any I comma j, right? Any I comma j. So from I comma j, I'm having two options. Either I can go down, that means I plus 1 comma j, or either I can go right, that will be I comma j plus 1, right? These are the two possible cases. Similarly for here as well, I can go down, that it will be I plus 2 and j will remain same. And here I can either go right side, right means I will be same and j will plus 1 for right. Similar things will happen here as well. If I am at I comma j plus 1, for going down I will be doing I plus 1, and the right, the column will be constant. And here if I'm going right side, in that case the column will increment by 1 and the row will become constant, right? So these are the cases. So can you see that for every position we are having two cases, either this or this, either this or this. For this also either this or this. So that means in our code we are not sure that which to take. So let's put this decision on the dynamic programming and use dynamic programming in this solution. And using dynamic programming we can put these two cases, that either we can go right, either we can go down, right? So I will be having two moves. Let's start by solving this problem. I would say that int, the move will be one move will be the right. I will have one function basically which will help me to solve this problem, right? Int solve. I will have my vector in it. Now what I will do, I will say that one move is that move right, right? Move right. In move right, what I will do, I will have to check what is the element, right? Int element at in the grid where I'm standing, it will be grid of I comma j, right? This will be the element, but where from where I will get I and j, I will pass here int I comma int j, right? Let's say I'm having int I, int j. I'm having a position value, right? Indexes, and I'm having the maximum cost that I can incur. So I can get the element value as grid of I comma j, and if I am moving right, so I will check if my element is equal to 0, right? There are two cases: element might be 0 or element might be 1. So first, initially, actually, we should check if we want to move right, then if right exists or not. Means can we go to right? If we want to go to right, then j plus 1 should be less than the total number of rows. Let's consider that the total number of rows is n and total number of columns is m, right? So if I want to go to right side, see if I am here, if I am here at 0 comma 0, I want to come to 0 comma 1, then what I would do is I would just increment the column value by 1 and I will keep the row constant, right? So I will check if I want to increment int new row. Let's say new row is, row will be same, and int new column, this will be incremented by 1, right? So I will check whether this is possible. Like if new row, new underscore row, this should be less than the maximum value of row, and new underscore column, this should be less than the maximum value of column, right? M. If this is possible, then what I will do is If this is possible, like we can go to right, then I will calculate the value of of the element, right? If I want to go to right, then I will calculate the value of that element. That is new row, and this will be new column, right? I'm having element. Now I'm having decisions like if element is 2, or else if element is equal to 1, right? And else if like else element will be 2, right? And after that, so what we want to do if element is 0, what we want to do is that we will be having one cost. Sorry, we will be having one score that will be initially 0. What we want to do is now that we want to increase their score, but let's say score will be um, score is when I'm moving right, right? Right score. So what right score will be? Right score will be equal to, for 0, here we have to add 0 to our cost plus. Then okay, I have moved one right, but now I don't know after that where to go. So I will call my function again. It will decide what to do. I don't know. I just moved one step right. I don't know what to do. So I will call my function just, and I will pass all this function. Now the value of k will remain k because I haven't used any cost. Cost will be still be 0. Accumulating cost will be 0, right? But now my new I and j will be new row and new column, right? New row and new column. And my n and m will be constant because that are the maximum value of row and column, right? So this will be my first right when I'm moving to right. Okay. So what will be the right score in case of element is 1? So I'll just copy this here. I will paste it here. What I can see that for 1, I will be adding 1 to my score, right? Actually, we are having element here, so we can use here element. Okay. So what here we are doing that if it's 1, then add 1. That means if element will be 1, we will be adding 1 to our right score. And what we will do is that we will decrease 1 from our cost, right? 1 from our cost, and then just it will be new R and new everything will be same. And for 2, you can see that we don't need a condition because if the element is 1, then it will add 1. If element is 2, it will add 2. And cost actually we are decrementing by 1 only. So this condition is enough. That means understand that if I am at 0, comma 0, I am saying that just move one step right, and then I don't know what to do after that. So I'm just calling my function. It will decide what to do in the next iteration. That's what I'm doing. I'm moving right. This is this is about moving right. Okay. So moving right, I am doing this. I am just saying that I am at 0, comma 0. So I will add 0 to my initially look, if I am at 0, comma 0, so I will be having 0 in my score, cost will be 0. If I want to move 1, I want to move to 1 right, so I will just add that 1 to my score and cost. That's it. And after moving to right, after coming to right, I won't decide. I don't know where to go down, whether to go right. I don't know, so I have just called my function. That's it. This is how dynamic programming works, right? So this is one part, moving right. As we have discussed, we have two parts. For every element, we have two parts, either move right, either move down. So let's check for moving down. For moving down, what I will do is uh, my new row will be incremented right, and new column will become j, right? So I will again check if this new row is less than n and the new column is less than m, right? If this is there, then what I will do is I will calculate the elements same as done in the above, right? This step will be the same. I have calculated the element. Then what I will do is it's a down score, right? It's a down score. It's a down score. Let's make it 0 initially. Now what I will do is like if element is equal to 0. So what I have to do, I have to do the same thing. I can copy this here as well. This will be the same, right? This is the same. Just the value. Just the thing is that my indexes have changed. Nothing else. This thing will become exactly same, right? That's all. Just my this will be the moving down. So I will do down score here. I will use down score. I will use down score. Okay. So what I have to do now, like see, I one. I was at 0, 0. I decided to move here in one move. That was my first step. And on the second end, I also decided to go down. Right? I decided to go right. I decided to go down. Now from after right, I don't know where I am going. I am going either down or I am going right. I don't know. And even after coming here, I don't know if I am going right, if I am going down. But if some path exists to this, then I have to consider that. And if some path exists on this way, means from this way or this way, if any of the path exists, then it should give me. Sorry, that's not. That's good. So yeah. So in either in this path or either in this path, I will get answer right. So I want to consider the maximum answer, right? So what I will do is that just I will do return maximum of right score and down score, right? So now these are actually defined inside the block. So I will keep them outside the block so that I can access it outside this block, right? Outside this if block. I will just move this outside the if block. Okay. That's it, nothing. So I will say that I don't know, just return the maximum from both. From wherever, whichever path I'm getting maximum answer, it's return me, right? This is what my DP looks like. Okay. But now I should be having base conditions, right? If my index is going beyond the given limit, right? If my j plus 1 is going beyond the limit, because when will my function return? I don't have any return conditions, right? Let's say if my cost becomes less than zero, if my cost becomes less than zero, then I should be considering very minimum value. That don't consider this case. If my cost is becomes less than zero, then that means the path doesn't exist and don't consider this. Just eliminate this, right? That's what I'm saying. Just eliminate this. And second condition, what second condition can be is that if let's say if I have reached to my destination, if that means if I is equal to m minus 1 and j is equal to n minus 1, that means I have reached to my destination. Then I will say that okay, consider this path, I will return 0. That is a positive sign that I have written. I am at the position, see, even if I am reaching here, if I am reaching here, like let's say I am at 0, I was at 0 comma 0, I came to 0 comma 1. Then when I will be reaching here. Then in the new function call, I will be already calculating this. I will be calculating 0 as my score, and I will be also adding 0 to my cost, and then I will be proceeding further, right? So I have already taken that into account. So if my I have reached my destination, right? If I is equal to m minus 1 and j is equal to n minus 1, that means I have reached my destination, return 0. This is the acceptable case. Okay. So let's see if this works or not. Let's just call our function. We will pass the elements here. We are starting from 0, comma 0. So I'm passing 0, comma 0 as the initial value. And my total rows will be grid.size, and my total columns will be this. Then I will try returning the solution here, right? So can you see one thing, that I want to return the maximum score here, right? Okay, sounds good. Let's see if this works. So we have got a compilation error that I am not giving a semicolon here. Let's run it again. So our answer is not correct. So also understand that if I am standing at 0, comma 0, right? So at 0, comma 0, if I am standing, so I should consider that at at 0, comma 0, here this one constraint is there. Grid of 0, comma 0 will always be 0. That means wherever I am standing, it won't incur a cost, or it won't even incur me any kind of profits, right? Score will be 0 and cost will be 0, right? This will one, or either I can add 0 as well, but that will be the same condition. I want to say that for the first element, I am taking it, score will be 0 and cost will be 0. That's why I'm doing k minus 0, right? And then from 0, comma 0, I'm starting, and then I will go to right and I will go to down as well. So let's understand why our results are not coming correct. What we are doing is here. So let's discuss why our solution is not coming to be correct. Let's take this first example and try run it. It is 0, comma 1 and 2, comma 0. So according to our solution, what should happen is that we are passing grid here, k here, 0, comma 0 starting and this all things. Okay. So what we'll do is that is k is less than 0, return int min, k is not less than 0, it's 1, right? So it won't return, it won't go into this, and I is 0, 0, so it won't go into this. So our new row will be 0 and our new column will be 1, right? Because we are moving right. So our right score will be 0. Okay. So our right score is 0 now. So our new row is less than n and our new column is less than n, which is true. Like we are in the range. So what we'll do is element of new row and new column we have taken. We have done at right score is equal to element plus solve. That means what will be our right score here in this case? Uh, let's take it as our right score will become 1, right? Because element here is 1. And what will be our cost here? It will also be 1. I will just remove this. So our cost will also become 1. So we will come to the we will come here right after that. So if we are coming here, so this will go here because element here, element value will be 1 here. Okay, so else if yeah, here we are giving a mistake that we don't want to check if it's 1 or not. For either 1 or for either 2, this should work, right? Because here element will come and cost will decrease by 1, because for 1 or for 2 we will be adding the element and the cost will be decreased by 1. So see, now this is for the second test case where we are getting a wrong result. For k is equal to 1, output is equal to 1, expected should be minus 1. That's what that means. What we should do, right? Because 0 can also be a valid answer. What we should do is we should use right score and down score as int min, because sometimes potential answer can become 0 as well, but 0 is not the true answer. Means the answer can come 0, but 0 is not a valid answer. That's what I'm saying in this case. Like if you will say 0 1 1 comma 2, so what will happen here na? 0 1 and 1 comma 2. What will happen here is that if my k is equal to 1, right? For the second test case my k is equal to 1, I will explain why this is failing. K is equal to 1, right? So what will happen that when I'm starting from here, I will go here, my right score will become 1, right? My cost will become 1. I'm standing here. If I will go down from here, then what my cost will become is my cost will become 0, right? Sorry. My cost is 1 here, right? When I will come here, my cost will become 3 because 2 will be added to it, and my cost will become 3, and my right score will become 1 plus cost will become 2, sorry, because cost is increased by only 1, but my score will be increased by this. It will total become 3. Can you see cost is 2? That means and k value is 1. So this is not acceptable solution. Means going from this to this to this is not an acceptable solution. That means this won't be accepted, right? And i- and if you will go down, if you'll go down, this is a similar case 0 1 2. So this again won't be accepted. The thing will be same here. So this is this is not an acceptable. There is no path exists. So answer should be minus 1. Why our answer came 1? Let's understand why our answer came 1. Because when we started from here, initially we were having right score and down score as 0, right? So for right score, what happened? For right score, we did as right score became 1, because it was valid. Then what we did, we tried going right again, but we were unable to do. So we tried going down. If we are going down, our score will increase by 2. That means this condition will be hit, right? Because I am decreasing it, right? K minus 1. So it will return int min. But then as I am doing here maximum of this, so my one of the score will be 0 and one of the score will be int min. So maximum will I will get as 0. But actually 0 should not be returned because here no path exists, right? So that is why we are changing it to int min. Because if int min is coming, that means it's a signal that no path exists. That's why we are changing it to. If we will make it 0, if it is not going in any of this, let's say for down score it is not going in any of this, but from up score we are getting int min. So from up score right, sorry, from right score we are getting int min, and from down score we are having 0 here. So it will return 0. That's valid, but we should have some invalid condition where we can say that this is not working, like no path exists. So that is why we are making it int min, right? So now let's check by executing this what happens. This will again give us something wrong and I will try to fix it. See, here this gave us the output as int min. That means this is a signal that our answer doesn't exist, right? So what we will do is we will say that this should be maximum of -1 or this. That means if this is int min, right? If this is int min, then I don't want this. Return -1 because that will be my answer, right? Because it's an invalid case. Let's run this program. So this all conditions are satisfied right here. All conditions are satisfied. If I'm trying to submit the solution, let's see if it runs or not. So it gave us a time complexity exceeded issue. Now why it gave a time complexity exceeded issue? That is important to understand. Let's come to constraints here. So in constraints we can see that our m and n is 200. Let's see what is the time complexity of our code. First thing, what is the time complexity of our code? Now from our code I have explained you that we have two conditions, right? Two conditions for every I and j. We are going in the two possible cases, either left, either right. And for means for every cell, I'm having two cases, right? One cell, two cases. So if I am going to a second cell, from one cell, if I am going to second cell, then from that second cell, I am again emerging about two cases, two more cases, right? So for if I am having one cell, then what will be my time complexity? It will be two to the power 0, right? Because I am having only, I am at a single cell and I am at the answer. Like if I am standing at m minus 1 and n minus 1, and that is the only one cell in the exist in the complete grid, means the size of the grid is 1 comma 1, right? So I am my starting cell and ending cell is 1. So I'm starting at the same cell. So I will be having what will the possibility? It will be only one, right? I am getting the answer. But let's say if there are more cells, let's say there are 2 comma 2, right? 2 by 2 matrix we are having. So what we can say that from each cell I am having two cases. I can go right, I can go down. Then if I am coming at this cell, I can go right, I can go down, right? This. So as the number of cells will increase, our complexity will also increase with the factor of 2 to the power of number of cells, that I want to say, right? Because like in our case, what will the maximum number of steps that we can take, like from 0 to, from here, if I want to reach here, from 0 to 0, and if I want to reach to m minus 1 and n minus 1, what are the maximum number of steps that I can take? I can only go right, I can only go down. So maximum number of steps that you will find will be, they will be m plus n minus 2. That will be this. Because see, 1, 2, 3, 4, 5, 6, 7. That means our answer will come to 7, right? Because what is the m value here? M is the number of rows, right? 0, 1, 2, 3, 4. Means total 5 rows, right? So I will have 5 here. What will be n? N is the total number of column. 1, 2, 3, 4. That will be 2. 4, sorry. That will be 4. So 5 plus 4 minus 2 equals 7. That's true. So maximum number of steps that you will take from here to here, that cannot exceed m plus n minus 2. That's what I want to explain. That means our time complexity will be, means when I when I said that it will increase as the number of cells increase, because for every case, because it's a recursion, when you will, when you are at this cell and you are going to this cell, this is preserved, this should also be considered. You can't say that it will be lost, right? So it's a recursion thing. So the time complexity here will be 2 raised to m plus n. Okay, so what is the time complexity here? Let's see. It will be 2 to the power m plus n. That will be the time complexity for our program. Okay. So what will the value of m plus n? Here m is 200. Maximum value of m is 200 and n is 200. So 200 plus 200, it will be 400. So what will be the our time complexity will become 2 to the power 400. Do you know what is 2 to the power 400? It will be 10 to the power 120. Now our operating system can only perform 10 to the power 8 operations in 1 second, and the time complexity is coming out to be 10 to the power 120. Can you imagine how long this time complexity is, and it would take, it would not be successful, means this solution won't work, right? So that is why we are getting time complexity. So can we optimize it? Yes, we can optimize it. We can use memoization. What is memoization is, we can memoize our means if we are visiting at a particular cell, and for that particular cell, if we are getting the possible answer, we will store that answer, and whenever again in the meantime again if we are visiting to the same cell, then we won't perform the complete actions, but we will use the stored value. That is what memoization is. I will explain why I'm creating this vector and everything. Don't worry, I will explain these things why I'm creating this vector. Just just be with me and I will make it very clear. This is DP and I will also pass this here. See, I'm just passing a single, I'm passing a 3D vector here, right, in the function, and I'm passing it as arguments here in the function, right, wherever I have called it. And I also passed it in this function, right, here also. I have created one 3D DP. So we'll memorize this solution, right? So what we will do is that, let's say, now why I have created this, because you can see in our function there are three changing parameters. What is changing, like when I am calling this function, what is changing? K is changing, k is decreased by -1, new r means value of I and value of j is changing, right? Means these three things are changing in my function. You can see this. Only these three things are changing in my function. Int n, m, these are constant, right? These are constant, these are not changing, right? And this grid is my input, this is not changing, this is a DP that we are using. So there are only three things that are changing. So based on how many things are changing in our function, our dimension of DP will depend on that. So there are three things changing in my function, so I will be using 3D DP. So I have used this vector. So what will happen is, whenever I am getting a score, whenever I am getting a, what is this calculating single function? This is calculating a score when there is some k value, there is some I value, there is some j value. I don't know. There may be some combination of this tuple. For this tuple, I will be getting this value. This value is for the specific tuple. For that tuple, I will store that value. Means I will do dp of I, dp of j, and dp of k. I will store that value with me. So whenever if the same combination is hit again, then I shouldn't be performing these all operations again, but I will take this value again. From where I will take? I will say that initially I have made all the elements as -1. So I will say that if dp of this combination, if I comma j comma k, if dp of this whole couple, if of this for tuple, if for this, if the value is not equal to -1, that means we have already calculated the value and written that value, and don't calculate it again. That's what it means. So I'm returning it. That's it. And let's see if this works or not, and if this solves our problem, and what is the time complexity for this. So it's giving some issue that, okay, we have passed. the function somewhere else. We're expected to pass it somewhere else. Let's pass it here. That was a syntactical error. And let's check if it passes. Yes. So our problem, the test cases are accepted. Let's check if it is within our time complexity or not. Oh, so it's giving wrong answer. It's giving wrong answer. The output came out to be -1 for some of the one of the test case for this one. So let's check the code. What's wrong here? We have created a DP and oh, okay. So output has came as -1 and expected was 7. Okay, let's check what's wrong in this. Uh, mm, mm, Actually, everything looks correct, but one of the test cases is failing. Mm, what can be issue? Oh, okay, so I understood the issue that was here, and the issue is that here I'm having number of rows as n, so I should be checking here as this. And this should be m-1. This was the potential issue. Mm, Now this looks correct to me. Let's try running. Let's try running it. Let's try to submit if it's submitting or not. Let's see. So it is accepted. The issue was that I was just checking up with between I is equal to m-1 and j is equal to n-1. There was a mistake and rest the code looks correct. So this was it. And why it is passing and why the previous code was not passing. Previous code was not passing because the time complexity was very high for the code. But what was the time complexity for this? Time complexity for this program will be big O of m comma n m multiplied by n multiplied by k, because here for every index we are coming only once at every index, right? Means every combination we are having a combination here, right, of this tuple I, j and k. Here we are doing, and if we are saying that if the value is calculated for this I, j and k, if value is not equal to 1, that means we have calculated the value, means for this combination we have done this. That means return the value, calculated value. That means for a single combination of I, j, k, we are not calculating it again. That means for I, j and k we are traversing this tuple for once. Means if I is, let's say, the maximum value of rows is 5 and maximum value of columns is 5 and k is also 5. So for every combination from 000 to 555, we are only going once at all combinations. So that is why the time complexity for this program will be n times m times k. Okay. So yes, that was the third problem. Thank you for attending and keep learning.